I am Rishi Gupta and this is my ELL project. The topic of my project is strain gauge. So what is a strain gauge? A strain gauge circuit is used to measure strain on an object. When an external force is applied on an object, there is a deformation in the shape of the object. This deformation in the shape is both compressive or tensile, is called strain, and it is measured by the strain gauge. It converts a measured analog quantity into an electric signal. The strain gauge consists of high resistance fine wire, thin foil grid, and is securely bounded to a specimen. When the specimen undergoes a stress, the resistance of the strain gauge is changed. So the working principle of the strain gauge. The strain gauge is sensitive to the small changes that occur in the geometry of an object. By measuring the change in resistance of an object, the amount of induced stress can be calculated. Now we see the working of the strain gauge. The change in resistance normally has very small value, and to sense that small change, strain gauge has a long thin metallic strip arranged in a zigzag pattern on a conducting material called the carrier, as shown here, so that it can enlarge the small amount of stress in the group of parallel lines and could be measured with high accuracy. The gauge is literally glued onto the device by an adhesive. When an object shows physical deformation, its electrical resistance gets changed and that change is then measured by the gauge. Now measuring the value of resistance is fairly easy. We do that by using the concept of Wheatstone network. Let's say if the unknown resistance Rx is to be measured and resistance R1, R2 and R3 are known, where R2 is adjustable, then if the measured voltage V0 is 0, both legs have equal voltage ratios. Now, the output of a string gauge within a Wheatstone bridge circuit is relatively small. Typically, most such strain gauge outputs are less than 10 mV per watt or 10 mV of output per volt of excitation voltage. For these low voltage signals to be of value in a measurement system, they must be amplified to a higher level. So for signal amplification, the amplifiers consist of two inputs and one output, in which output is ideally proportional to the difference between the two voltages. Schematically, an instrumentation amplifier looks identical to a standard operational amplifier circuit. The difference is that the former is almost always internally composed of three operational amplifiers. These are arranged so that there is one op-amp to buffer each input and one to produce the desired differentiating output. The variation of temperature can also affect the working of string gauge. If the temperature is more, resistance will be more, and if the temperature is less, the resistance will be less. This is a common property of all the conductors. We can overcome this problem by using string gauges that are self-temperature compensated or by a dummy strain gauge technique. Here is a quarter bridge strain gauge circuit. So whenever temperature changes, the resistance will change in the same proportion in the both arms of the rheostat, and the bridge remains in the state of balance. Effect of temperature gets nullified. There are also half bridge and full bridge strain gauge circuits. Here are some uses of string gauge. They are widely used in the field of mechanical engineering development to measure the stress generated by machinery, in the field of component testing of aircraft like linkages, structural damage, etc., vehicle testing applications, construction applications. That's it from my side. Thank you for watching the video.